Hi, today we're going to talk about evaluating geometric series, but some special cases. So let's consider this series 1/2 plus 1/4 plus 1/8 plus 1/16. I hope you can see that this is a geometric sequence that has the common ratio of 1/2. If you keep multiplying 1/2 by half, you get 1/4, multiply that by 1/2, you get 1/8, etc. So we're going to start adding terms. We add the first two terms together, that's 1/2 plus 1/4, that's going to give you 3/4, which is 0.75. The first three terms will give you 1/2 plus 1/4 plus 1/8 is going to give you 7/8, it's going to give you 0.875. Four terms will give you this number. So the question is going to be, if we continue adding more and more terms, what's going to happen? So let's try to visualize this. So we have this interval from 0 to 1. So halfway there is 1/2. Right? How do we get the fourth? The fourth is 1/2 of a half. So if we cut the remaining portion in half, that's 1/4, and that's actually 1/2 plus 1/4. To get 1/8, we're going to split this remaining section in half. That's 1/8, and this here will give us 1/2 plus 1/4 plus 1/8. We split this in half, one more, we can add 1/16, then 1/32, 1/64, and you can continue this process forever. But it looks like everything's gonna move closer to 1. So, with geometric series it is possible that you can add infinitely many terms, but you are going to get a finite sum. You call such series convergent. If it's not possible to obtain a finite sum when you try to add the terms of a geometric sequence, then you call that series divergent. So when is it going to be possible? There is only one condition that you have to go by, and that's that the absolute value of r has to be less than 1. So it doesn't matter what r is, as long as its absolute value does not exceed 1, then it actually has to be less than 1. Then you're going to get a series that's going to be convergent. And if you want to find the sum, the infinite sum, this is the formula. It's a very simple formula. You just need the first term and the common ratio. Okay. So if we go back to the problem we just did, the first term there was 1/2, and the common ratio was also 1/2. Remember, we multiplied 1/2 by 1/2 to get 1/4, and multiply 1/4 by 1/2 to get 1/8, etc. So the sum is going to be, the infinite sum is going to be 1/2 divided by 1 minus 1/2, which is 1/2 divided by 1/2. And yes, I think we had that feeling that everything's going to move closer to 1, and the infinite sum is going to be 1. We're going to take a look at some problems. So there are two questions that each problem is going to have. First, we need to determine if the series is convergent or divergent. And if it's convergent, find the sum. If it's divergent, you cannot do it. So, and all that, to answer the first question, you need to look at the common ratio. So the common ratio here is, I hope you can see, -3. So if you take the absolute value of that, it's the absolute value of -3, which is 3. It is greater than 1. This series is going to be divergent. And we do not find the sums, as we cannot find it. One thing that I forgot to mention here, please note that the upper limit of your summation here is going to be infinity. Okay, so we're done with number 1. Let's take a look at number 2. The common ratio here is actually 1/3. I hope you recognize the pattern. When you have some number to the power in any form in such expressions, that is basically your common ratio. So the common ratio is 1/3. If you take the absolute value of that, it's still 1/3. It is less than 1. So we have a convergent series, which means we can find the infinite sum. We do need to find the value of the first term. Substitute 1 into the formula, and that will give you 1, because you're going to be doing 1/3 to the power of 1 minus 1. That is 1/3 to the power of 0. That's 1. So to find the sum, we're going to use the formula. The first term is 1. 1 minus 1/3. It's going to be 1 divided by 2/3, which is actually going to give you 3/2. This will be the infinite sum of that. Okay. Continue on. Same question. We need to determine that for this sequence. So let's see. The common ratio here looks like it's 2/3. If you take the absolute value of that, it's still 2/3. It's less than 1. It is going to be convergent. And we are going to be able to find the sum. We still need the first term. The first term is going to be, we need to substitute 1 into this, so it's 4 times 2/3, which is going to give you 8/3. And our infinite sum will be, the first term is 8/3 divided by 1 minus 2/3. Let's see what we're getting here. This is 8/3 divided by 1 minus 2/3, going to give you 1/3. This whole thing will give you 8. The next series here, we have this. It's not given to us in a simple form with the sigma, so we're going to have to figure out a little bit more. So first of all, what do we have here? We know the first term is -5, but what's the common ratio? Because before we start going through all this trouble, we need to know that the common ratio is less than 1. So 25/4 divided by -5, that will be 25/4 times -1/5. And it looks like the common ratio in this case will be -5/4. If you take the absolute value of -5/4, it is 5/4, and this is greater than 1. So the series is going to be divergent, and we do not find the sum as we cannot do that. Okay. And one last problem here, this series here. So let's see. We need to find the common ratio. So for the common ratio, we're going to take 6/15. We're going to divide it by 2/3. It's going to be 6/15 times 3/2. And it is going to give us, what are we getting here? 3/5, right? And that is, if you take the absolute value, still 3/5, which is less than 1. So the series is going to be convergent. And we can find the sum. So the infinite sum here is going to be, oh yeah, we have the first term, sorry, 2/3, 1 minus 3/5, which is going to be 2/3 divided by 1 minus 3/5 will give you 2/5, and it's going to end up giving us 5/3 as our final answer. Okay. If you have any questions, you can always put them in comments, or let me know what else you need help with. I hope this helps.